In this video, we're going to go through how MusiCode V12 works under the hood. So I'm in the MusiCode V12.py file, and the first section here is going to be importing all of our dependencies. So we have some for data processing, plotting, signal processing, working with wave files, and some other things. So a really important thing, there are two primary classes that we'll be working with. The first one is the MusiCode class, and then down here we are going to have the wave class right here. So these are two distinct separate classes which kind of work together to do everything for MusiCode. So we'll start out with the MusiCode class. And the best way to think of the MusiCode class is it's like a generator. It generates wave objects. So the whole point of MusiCode is to generate wave objects. So create wave, sequence, chord, arpeggio are all methods within the MusiCode class. And so this is why we say m.createWave. And so before we get into all the methods, we'll go through the attributes. So here we're setting up the sample path, the time mode for relative, which means essentially working with rhythms that are quarter notes and eighth notes rather than just seconds. And then it allows us to define a BPM. So we have our sample rate, and then we have our chords, which is all of the chord information for the chord method. Next we have, here we go. So this is going to be a really important part for integrating MIDI, because these two things right here need to be mapped to the MIDI values. So what are these things here? So this is actually the table of frequencies and musical notes. So let's go ahead and check out this in a Jupyter notebook. So we'll say that, and so here we can see our list. And so what this does is it takes a value here and it converts that into a frequency. So all MIDI is it's a collection of different labels. And so if you wanted to create something that reads MIDI, then if you can take each MIDI event and translate it into something like this, and then also give it a duration value in a given BPM, then you can essentially convert any MIDI to any, pretty much any like audio, and that would be pretty dang cool. So we'll get into that. So a few other things just in the initial, the init function, which initializes every time a new MusiCode object is created. So we have our sample library here. So these are just different file paths that take us to the folders that are right here. And then that allows us to draw out the different categories of sounds. So we have some getters and we have some setters for BPM and time mode. Okay, so we can see we have create wave here. So remember, this is a way to generate a wave object, and a wave object is the primary form, the data type that we're working with. And so it'll create a wave, and you'll see that it's creating this self.waveform. So self.waveform is like the big thing. This is, every object is a waveform, and it's defined as self.waveform. So you can see that for sequence here, we're going to have self.waveform and self.waveform. And this is a very important line here, because what we're doing here is we're actually creating a wave object with this line, and then we're passing in the numpy array into here to convert it into a wave object. Because you can see here we're actually applying numpy operations, and we're treating this as a numpy array. But in all of these methods, sequence, create wave, we don't leave it as a numpy array, we actually convert it into a wave object at the end. And the reason why we do this is so that we can apply the different methods like loop and time edit. These are all methods that work with wave objects, but not with NumPy arrays. So it's really important to make sure that all of these are converted into a wave object at the very end, and then stored in self.waveform. All right, so then rest's pretty much the same deal. So we have a wave object, and then it's kind of a mess, but we're taking zeros. We're just creating a bunch of zeros and then making it into a wave object given the rhythm. Right? All right, so we have arpeggio. These all essentially follow the same pattern where it's going to treat it as a NumPy array for the majority of the process, and then at the very end it's converted into this wave object. Okay, so another few things is we have join waves, and so join waves is going to concatenate these things together, and we can actually see that we are using MP concatenate right here. So we just have some code to deal with stereo and mono to make sure we don't run into errors there. And then pretty much same deal with add waves, except it's vertical. Okay, then we have sample, and sample is essentially just looking through the different folders, fetching the file paths, and then loading the audio using sound file right there. And then again, the samples are stored in self.waveform. So every self.waveform is a wave object. So we can see wave here, and so we have this as a subclass of the MP array. So we have some code to basically create a copy of an MP array, and we can see that we've inherited many different methods and attributes from the ND array right there. Okay, so then we run some initializing with the init function, and then we set up some of our attributes, and then we have our notes and frequencies. Okay, so here we'll see that what we're doing is we are calling different operations on self.waveform. So we can see self.waveform and then self.waveform. We're working with the same thing as up here, the self.waveform here, and the one below are the same thing. So it's important to understand that the MusiCode class, why am I scrolling? Okay, the MusiCode class is the generator, and then its job is to generate wave objects, which are defined here. So let's just go through this. So we have time, which is going to tell you the duration in seconds of any waveform. We have volume, time edit. We have join waves, add waves. So we need these in both classes because both classes depend on them. So they're just both in there to make things a little easier. So then we have our bounce, we have view, we have loop, pan, fade. Fade is kind of long. Low pass filter, high pass filter, reverse, LFO. Okay, so that gets us to the very bottom. So let's just take a look at one of these. So let's maybe look at something here. So we'll look at time edit. So time edit, again, is going to be operating on the self.waveform, which we can see right here. And so it's modifying itself, if that makes sense, right? It can apply an operation on itself. So what that could look like in practice is we're going to create a wave object like this. Oops, okay. So we create a wave object here, and we can see that it's a wave. We could also do this, and we could check the data type, and we're going to see that it's MusiCode V12 wave object. Okay. So, but we can see that it's actually being called off of M. So again, MusiCode, the class, which M is defined up here. So we'll just take that code, bring it down here. So we create a MusiCode object, and the MusiCode object is a wave generator, right? So when we create a wave here, what we can do is we can apply different things directly to the object to modify it in place. So we can say dot loop 2 times. So it's going to take the wave object created by this line, and it's going to be that self.waveform, which will then be modified, and then self.waveform is updated with the new looped value. And you can actually just keep chaining different things. And so we could say, go ahead and apply a fade, and we'll do fade in equals, 1. So now we've applied a second operation. So it creates the wave object here, and then it updates the value, the self.waveform value, to loop twice, and then it updates it again to be dot fade, just to have a little fade in. So this is all one object. So instead of having to work with multiple variables and things like that, you can sort of apply everything you need to directly onto one thing. And so if I needed to pan this, just say left 45, and then we could even use that delay and say delay. So delay could be similar to these in that it's an effect that can be applied directly to a wave object. Okay, so going back here, so the important 2 things, first about MIDI. If we're going to do MIDI, what we need to do is first focus on this key, because what we need to do is we need to be able to take any MIDI event and essentially create this, a map from MIDI notes to this. And let's see about Python MIDI. So there's some things here that would be worth considering. So we have Mido, which is one I've looked at a little bit. And then we also have this Vishnu Bob, nervous system with a coding habit. Thank you. Thank you so much. And then what we might be able to do is work with this and sort of integrate it into the system. So what would be a good thing to do is start working with this and learning your way around this library, and then we can figure out how to merge the two. But we need to create a map from MIDI events to something here, and then that way we can translate a MIDI note into a frequency value that can be passed into the create wave statement. Okay, so the second thing, if we go down here, so for adding delay, if we wanted to, for instance, add a new method to the wave class to alter the signal in a new way, let's go all the way down. So what we could do with delay is we create a function, or I guess a method, and it's going to have the self, because it's going to be modifying self.waveform, which we can see here. So it essentially behaves the same as a normal function, except you have this, and you're operating on self.waveform, and then you'll see here we have the familiar conversion from NumPy array into the final waveform wave object, and then return that there. So you can use this as a model, or really any of these you can use as a model for how to add a new method to the wave class, and then you can test it out on wave objects to make sure that everything works properly. And so yeah, that is an overview of everything. I really need to go through this and do more detailed documentation so that people can start building more on this. And there's some things I want to clean up and sort of redesign. And so if you have any ideas, just let me know. If you have any ways to make this better, I'm just trying to, really think of everything I can, trying to make it efficient so it's not too long, people have to wait. Just trying to make this as intuitive as possible so that creating music with code is sort of a seamless process and not a laborious one. And so all the little adjustments and updates I think will be really nice, and we'll just keep iterating, keep making it better, and we'll take it as we go. So that's it for this video. Peace.